of Jacob Asukwo of Nigeria. I'm part of the organizing team of 10 Machine Uyo. So originally it was TensorFlow Uyo, but now it has now changed to machine learning Uyo. So today we are kickstarting the first day of our bootcamp, and we'll be having sessions with Ephy Mucira from Kenya, who will be talking to us about computer vision with machine learning. Also, briefly to talk about the community, we have partnered with Aorist Artificial Intelligence Labs. We have also partnered with Computer Vision Africa, and we have also partnered with TensorFlow User Group Casablanca. So thank you everybody for joining. The chat is open. You can ask your questions and feel free to raise your hand if you want to ask any question. So our speaker is here already, and without wasting any time, I'm going to introduce him to speak. So Ephy Mucira is a machine learning engineer at Aorist Artificial Intelligence Labs. And so for this week, we are going to have sessions today and on Thursday, the same time and the same meeting link. And the next session will be around models for machine learning. Okay, and after today, we are going to have another session. We are going to kickstart ML Study Jam. ML Study Jam is a program designed that is going to run for 1 month, designed to teach you from basics to the fundamentals to the intermediate and advanced level of AI and artificial intelligence. So I would say we should introduce ourselves, but we can do that in the chat section. So I'm going to be in the chat section as well. So help me as I'm going to hand over now to our speaker to take us on machine learning with computer vision. Yeah, round of applause for him. So Ephy, you can take on and continue your session.
Okay. Thank you, Victor, for the opportunity. I appreciate.
Okay.
So, without further ado, we are going to start with a simple presentation on computer vision. Then, at the end of it all, we shall do one practical example of how we can implement computer vision. So, just a minute as I share my screen. So I hope you can see my screen.
Yeah.
Okay. So my name is Ephy Mucira once again from Kenya, and I am a machine learning engineer at a startup called Aorist Labs that deals with surveillance using AI. Yeah, and I think we're just going to jump into what we're supposed to do today. Just a minute. So as I stated earlier, we are going to start with this simple presentation on computer vision, and then at the end of it all, we will do a simple implementation of it using Python. So computer vision is a field of computer science that focuses on enabling computers to identify and understand objects and people in images and videos. Like other types of AI, computer vision seeks to perform and automate tasks to replicate human capabilities. So yeah, that is it. Computer vision is just a branch of machine learning, whereby we try to train computers on how they can identify certain patterns in an image. And at the end of it all, we make some good outputs. Then we have a simple presentation of how computer vision works. I think I'll just read what is there. So computer vision applications use input from sensing devices, artificial intelligence, machine learning, and deep learning to replicate the way the human vision system works. Computer vision applications run on algorithms that are trained on massive amount of visual data or images in the cloud. They recognize patterns in the visual data and use those patterns to determine the output. So this is just a simple illustration. Like the first thing is we put some inputs into a neural network, and then now we do some processing to it. That is the training part. And at the end of it all, the purpose of the training is for our dense network to understand the patterns. And at the end of it all, we get an input, which can be a classification, can be continuous, and a lot of other outputs. So this is just a simple presentation because computer vision is kind of trying to imitate what human vision does. So I think we all know this, that our eyes are able to view an object, and then then whatever has been viewed is taken to the brain, then the brain is able to interpret, and you're able to know whatever that object is. So that is how computer vision works in a similar way. But now the only difference is that the way we are able to input this data, we use something like sensor machines, some things like cameras and stuff. Yeah, that is how we get our inputs, or rather we can use data sets also. And then we are able to run them and train them using algorithms in our dense neural network, which later gives us an output. So the way computer sees, now today I'm just focusing on images, though we can also train our algorithms. We can use our algorithms to train models using other types of data, but for now we are focusing on computer vision, which is mostly the images. So this is just a comparison on how the computer views an image and how we as humans view that image. Like now, for example, this is the number 2. Now the computer does not just view it as like us. It views it as a series of numbers in between to 255. I think most of us are familiar with that. And then now it is able to identify some patterns in the object. Like now, for example, when you advance to learn more about convolutional neural networks, we will notice that how they work. Like they identify some sections. Like for example, we can have some neural networks identifying the upper part of the two, and then some other neural networks identifying the vertical part, which is the center one, and then some others identifying the one that is down there. And then now they communicate to another layer, which now goes to another one. Okay, like let me use this example that is here. This one. An example of how of the structure of a deep learning network or neural network. So we have this network that we are training that should identify this animal here. The animal is called koala. Yeah, I don't know whether you've heard of it. And then we are able to pass it through the CNN, which has some levels. And at the end of the session, we'll be able to know what is pulling all this rail we can see here and all that. So that is just an example. We shall get there. I don't think this slide was supposed to be here. But anyway, let me just go with the order. So we have some benefits of computer vision, which are just common, simple and faster processes. As you all know, computers are really fast in whatever they implement. Then it is reliable, doesn't get tired. The eye can get tired, but for the computers, provided that the neural network is there and working, it can never get tired. Then, depending on how you train your models, the data you use, the accuracy probably will be good, maybe 80% and something. But also it can turn out to be bad. We also have a wide range of uses. Yes, computer vision has so many applications, which we'll see. And also cost reduction. That is when it comes to manpower and labor, because these machines are able to occupy quite a number of industries where they reduce manpower, saving on cost. So I think I'll just go through the presentation really quick, and then at the end of it all, we'll be able to go through the practical parts. So we have the disadvantages. Data dependency. I think now this is one of the most challenging things when it comes to developing these models. Training is not, I don't consider training to be that difficult, but now where you get that data to train with is the problem. So that can be one of the disadvantages about data. And then also computation resources. There's a lot of computations happening in those neural networks, which might not be performed by any type of computer, rather than it can require some resources like the GPUs and stuff. And then we also have this common issue of overfitting and underfitting, which mostly occurs when you find that your model works very well on your training set, but now when you're trying to evaluate it with the testing set, it becomes very poor. But we shall see on how to address overfitting and underfitting. And then we also have cost because of the GPUs and maybe collection of data. We have the hardware constraints, and then sensitivity to domains. Models trained in one domain or on specific data may not perform well when applied to a different domain, requiring retraining or fine-tuning, which obviously adds more complexity into it. So this is just a diagram representing the way computer vision is broad, and I thought it would be necessary to show this the way it is related to other fields. You can see artificial intelligence, control, robotics, signal, physics, imaging. I think if I'll be able, I will share the slides in case one needs them, so that you can go through them. So this presentation is just supposed to maybe get you an overview of what computer vision is, how it works, applications, and basically those are the most vital parts. Then now we have these the process. So I really struggled looking for a title here, so I decided just to name it From Problem Definition to a Working Model. But I also think it's not bad. So the first thing, always, we do not just build models. We need to build something that is solving a problem somewhere. So the first thing is always identifying a problem somewhere and defining that problem. Then after that, you are able to ask yourself, like, what data do I need to in order to make this come to completion, and that is where data collection comes in. And it's not a must to do data collection because most of these things have been done. You can just go online and search for certain data sets, match whatever you're doing. Or maybe if you want, you can also make your own data sets. But I find that to be very costly and also time. It will take a lot of time. Then we have data annotation. I think we are going to see most of these things as we do the practical bit. That is the labeling of the images, because now of our computer will not be able to just understand the images themselves. Then we need to give them some classes or labels to represent the various classes that we have. Then we have data preprocessing. I think this one is just similar, like, I don't know whether you have heard of data augmentation. Yeah, whereby this one can also address the issue of overfitting, whereby you are able to augment your data. Like, for example, you can zoom. There are various methods in which you can augment: zooming, rotation. There are a lot. So I think you can also learn more about them maybe from YouTube, TensorFlow, and all those resources. And then now model selection. Obviously, the models that we have, or rather, let me call them algorithms or something, most of them may not perform well on certain type of data. So you need to consider the model you're choosing. You need to consider, you need to consider the model. Like, for example, now the YOLO one, this one is mostly used in object detection. And then we have the CNN, we also have the ANN, artificial neural networks, which can also work on maybe when you're building a model that can, like, for example, the practical bit, we are just going to use a simple model that is able to classify different types of flowers, and we'll be using CNN, convolutional neural networks. You can also use the ANN, but now there are some problems with it. The CNN will work better. Now, after that, we have the model training, model evaluation, then model tuning, that is the hyperparameters and all that. Model testing, deployment, and finally monitoring and scaling. Now, I think the most crucial part is the data collection one, maybe. That is mostly where people get a problem. But once the data is there, the rest is, I think, easier. So there are some key considerations that I saw necessary to maybe mention when building your neural networks. You need to look at the data quality and quantity. I think the more data you use to train your models, the more accurate it becomes, the more knowledgeable it becomes. So that is basically it. High quality, diverse, and well-labeled data sets are crucial. The more representative the data, the better the model's performance in real-world scenarios. Remember, we are not just building the models just for anything, but to solve real-world problems. Then this one, I think I mentioned, preprocessing and augmentation. Yeah, resizing, normalization, rotation, zooming. They also make our models work better in identifying the training set, the testing set. Then now the model architecture. I think we also talked about this one on maybe choosing the best. But I think machine learning is, in a way, it's a matter of try and error. You try this, if it doesn't work, you try this other thing until you get a good score. But now I don't see the reason why you should try some other unnecessary things, whereas there's something that will just work. Okay, I don't know. No, no, no. Let me just not say just work, but at least something you are sure will not disappoint. And then overfitting and generalization. Uh, so here in overfitting, you can address it by dropout regularization. That is, we will see this in the practical session, whereby you are able to add some dropout layers, and most of them actually work well after you drop out some neurons in your network. And then there's also this concept of transfer learning. It's not a must that you build your model from a scratch. They're already existing models. So you can maybe go to places like TensorFlow Hub. Then there are so many. Then you find a model that is kind of related on what you want to do. And then when you go to the documentation, probably they will provide the details on how to do that. And now I think the key consideration in this, in transfer learning, just need to freeze the training. Yeah, so some layers will not be included, like the ones for training the network, because you're not training again. You're just like trying to find a trained model and trying to apply it into your data or something like that. So I think I had gone through this. This is a simple representation of how our neural network works, of an example of how a neural network works. So there's obviously the input, which comes into the layers. We have our convolution here, and you can see this activation over here, ReLU. I think, okay, let me just continue. I'll come to that later. And then we have the pooling. You can also, pooling comes in when you want to do what? Let me find a way on how to place it. Okay, pooling in a way also helps in how, because there's you can find that there's some, when an image is represented to a computer in those RGB numbers, then it is not able, there are some edges that are not able to participate quite well in the computation. So pooling in a way tries to do that. Then we have the ReLU activation here, pooling again, and then our flattened layer here. I think with the time we shall be able to understand these things better, maybe by doing more practice and maybe through the practical session. And here for the considerations, these are not the only considerations. There are quite a lot, but I just limited them to this. So we have our tools and technologies. I just kind of looked for the most common ones. So I start with the framework and libraries, because for me, I mostly use Python. You can also use R, but I've not used R. Yeah, I've not used it. So I don't know much about it. But Python language has quite a lot of libraries and a very large community. So one of the libraries is TensorFlow, which we are going to use. Then there's Torch, PyTorch. It's just a deep learning framework. Then we have OpenCV. This one is designed to deal with the images, mostly image processing. Yeah. Then we have Keras. Keras can stand on its own, but I think now TensorFlow also comes with Keras inside it or something. Yeah. And then there's another part which is not really visible here. Very sorry for that. which is scikit-learn, sklearn. Yeah, it's also a library which has several models. Yeah, it's just like TensorFlow, but it's a bit, it can't handle uh, a lot of heavy stuff. Let me call them that. Yeah. So those are some of the tools which you can use. Then now we have pre-trained models and APIs. Like now YOLO, you can find it on GitHub. I guess there are a lot of tutorials on how to use it. Mostly I think on YouTube, and it is mostly used for object detection, which is also, I don't know whether I should call it a branch of computer vision, something like that. We also have ResNet, Google Cloud Vision API, Amazon Recognition. So for me, I've only been able to use YOLO quite some time back, and Amazon Recognition. For these ones, I've not interacted with them that much. Yeah, you remember me mentioning about data argumentation. There are also some libraries in Python which are specifically for this purpose. Though it's not a must to use them, you can just use the argumentation is it parameter or argument? Yeah, when defining your layers in your model. So there's this one, argumentations, argumenter. So basically they're just there to change the way the data is presented, because now when you're training your model, it's advisable not to train, like now maybe you want it to identify a lion. It's advisable not to train it using data whereby the lion is just facing one side or something. Maybe you can try when a lion is jumping, maybe when a lion is sleeping, different angles. Then we have some simple IDEs. Yeah. What is the full meaning of IDE? Something development environment, like now the VS Code, which I mostly use. We have PyCharm, we have Visual Studio Code, we have Jupyter Notebook, Anaconda, which also comes with Jupyter Notebook. We have also Google Colab, Kaggle. So maybe you're trying to build a model which actually requires a lot of computation, and maybe your machine has a CPU, it will not be able to do that very well. You can maybe use, I can advise maybe you use Google Colab or Kaggle, because in a way they allow you to use their GPUs, though I don't know whether they are limited. I'm not sure about that, but I think so. Then we have applications of computer vision. I think computer vision has really helped a lot in various sectors, like healthcare, where it is able to diagnose various diseases, especially the tumors. We also, I don't know whether I saw on LinkedIn or somewhere about these surgical AI powered robots, which I don't know did what surgery. No. It was a surgeon who did a surgery away from a distance, and the surgery was complete using this kind of technology, which is really transforming the world today. We also have autonomous vehicles, the likes of Tesla, whereby they have the sensors. Now those sensors are the ones that are able to input the data now, and it is able to identify various objects, like it is able to identify this is a person, this is another car or something, and then also lane detection. which lane is mine, which lane is not mine, and something like that. We also have its application on retail. I saw this video whereby when you go to shop in Amazon, you just they're using a technology there which is quite well. You just have to scan. I don't know what are you scanning when you're getting into the shop, into the into the shop, and then you just pick whatever you want and go out, and the money is checked out of your wallet, which is quite, I think, amazing. I think I would be happy to see those kind of stuff also here. And also customer analytics, like they are able to make recommendation systems depending on what they're able to make recommendation systems depending on the behavior of the user. We also have security and surveillance. What Aorist Labs is able to do is able to detect various kinds of crimes like shoplifting, theft. Yes. So it has been trained with various images. So now it is able to identify that kind of, do I call it label or class happening? And it is able to identify, is it shoplifting? Is it this? Is it that? So I'm very sorry for really rushing through the presentation. And I think if time allows, I had a small video where I wanted to show about applications of computer vision. Allow me to share my screen.
Computer science that deals with image classification, object detection, video processing, and so on is called computer vision. Due to advancements in deep learning, especially convolutional neural network or CNN, it has been possible to do amazing things in computer vision. In this video, we are going to look at some of the real-life applications of computer vision. The first application of computer vision is image classification and object detection. This is something you already have on your mobile phone. Once, me and my brother were walking in a park and we saw a plant which looked like a poison ivy, but we were not sure. So I took my Google Pixel, and Google Pixel has this application, Google Lens. Use that. It immediately told me that this is poison ivy. If you touch poison ivy, it can create a blister on your skin. So it is very poisonous plant. And that was my first experience of using computer vision for a real benefit. Also, when I'm having so many pictures, on my Google Pixel for finding pictures of fruits, I have to just write fruits, and it knows to identify those fruits. So it is doing image classification underneath, mostly using convolutional neural network, and finding fruit images from all the images. Even to identify people, I have all these people, my mom, my cousin, brother, everyone, their pictures are there in my phone. And if I want to find someone's picture, let's say Harsh Patel is my nephew, if I want to find his pictures, I just tag that this person is Harsh Patel, and the computer, using computer vision, it will identify the images. So the image search, the object detection has been so much accurate using convolutional neural network especially. The second application is in the field of banking. I never go to a bank to deposit my check. I have Bank of America account. I use my mobile application to deposit a check. When I take an image of the check, it will do image recognition. It will find out the check number, the amount, who is depositing the check, and everything. I'm going to play a short clip by Bank of America. This is on YouTube.
Depositing a check is simple with our Bank of America mobile banking app. Start by opening your app, signing into your account, and selecting Deposit Check. Then take a picture of the front and back of the endorsed check with your smartphone or tablet. Hold your device steady directly over the check, and the photo will be taken automatically. Once both sides are captured, you can select.
The third area where it is being used is agriculture. I'm again going to play a video from Cambridge Consultant. It shows how computer vision can help in agriculture area. You'll see a clip where it will be detecting the apples on a tree, and that can give you an estimate on your yield. As a farmer, you can predict how much yield you are going to get, especially when you have big farms. You can use like a drone and do amazing things in the field of agriculture. So let's look at that clip.
If we look back, the 20th century was all about making agricultural machines bigger, but this clearly couldn't continue forever. What we really need to be doing is looking after plants and soil at a more individual level. So to do this, we need to make machines smarter. And smarter means taking care of plants individually, weeding, spraying, and thinning, or identifying fruit, not just counting them, but providing yield and size estimates. What's missing is the ability for machines to discern plant health or to spot weeds amongst a crop. Artificial intelligence is about to change this. Machines can now be trained to recognize shapes and textures. The example you're seeing is using the texture of leaves to single them out as weeds or as plants that need special treatment. The commercial success of systems like these depend on taking into consideration the whole package, the software, hardware, and the business case. We've seen these technologies make huge steps forward, and we're already using them to deliver systems that just a few years ago would not have been possible. AI is making new means of farming possible, not just the machines, but the ways in which farming is done. So the question isn't, how will AI affect your business? It's how will AI improve your business?
The next application that you all probably know about is autonomous cars. Here in US, if you get Tesla Model 3 or any Tesla car, it has this autopilot feature, and I'm going to again play a clip. And it works. I have seen that working. People can also summon the car. So I was standing in a parking lot with my friend once, and his car was parked a little far away. It was Tesla Model 3, and he summoned the car. So car automatically came to us. Also, when there was a rainy day, and if my friend is shopping, sometimes he has a little child, so it might be hard to walk from the store to a parking lot because it rains too much. And on that occasion, he will auto summon his car, and the car will automatically come to his place. So these are again the real life application which I have personally experienced, and it is damn good. And all of this is possible because Tesla car has so many cameras. It will detect all the objects and do the decision making in a right way. All of this is possible because of deep learning and convolutional neural networks. The next big industry where computer vision is bringing revolution is retail. Here in US, in New York City and in Seattle, there are Amazon Go stores. You might have seen the video, but these stores actually exist. And all these applications which we have discussed so far, they are happening right now. It's not like some dummy video. In Amazon Go store, there is no employee. Everything is done by robots, cameras, and computer vision. So let's see a little video clip on Amazon Go.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go?
If you learned even a few new data skills, you'd probably make more money. And who doesn't want that?
What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going.
So that was just a small presentation. And then now I'm really sorry for taking a lot of time. So there's this small program I had gone through. This program is able to classify different types of flowers, and I'm using a data set that is already there. So I didn't make the data set. So these are the libraries we are using: TensorFlow for the models, matplotlib.pyplot for visualization of data, NumPy is for the mathematical computation, CV2 for the images, and yeah. So I'm just going to pass through it quick, just to give you an overview of how these things maybe work or something. So the first cell, I'm using VS Code. You can use any other editor, but VS Code is quite very slow. Then now the first cell was just importing the libraries necessary. Then now we have this other cell that is downloading the data and storing it into my current directory. So here in this parameter over here, cache_dir, you can input maybe the path of where you want to download the data. But for me, I just wanted to download it in the current directory, in the folder in which I am in. So that is why I have put a full stop there. And then now we have this globe functionality, which kind of really helps in a way, because you are able to see various paths in which your images are stored, and also it allows you to compute some functionalities like this. You're able to count the number of maybe images that have a certain extension. So this one was just like knowing about the data. So when the moment you have the data, you just don't just use it directly. You first need to know maybe what is there, how many are they, and stuff like that. So I think I'll just skip this part. Okay. So if I'll not show that for now, but if I go to my working directory, you will see that there's a folder called, was it flowers what? Flower photos, which has been downloaded, which was downloaded the moment I was testing this. And if you also run yours, it will be there. And then inside that, there are also other folders for the different types of, so the different flowers. And you can see there are 3,670 of them. So as I was saying, getting the data is the problem, because now how will you get all these photos, for training? And this one is just for flowers, but anyway, just by the way. And then now we can see we can be able to use the PL library for viewing the images according to their indexes. This one was just index 1. Yeah, you can view the different types of them. So this one is a rows, obviously, because we're in the. So let me just skip that part. We have this dictionary over here, whereby now it shows the different types of flowers we have. We have roses, daisy, dandelion. I never knew of that. We have sunflowers and tulips. And then now I am aligning it with a list of that type of flowers. Sorry. And then now, because for machine learning models, they are not able to, they only understand numbers. So it's a good measure for you to label your data. You remember about data annotation. So now we are labeling our various classes like roses, daisy, and whatever with various classes. So if our model predicts 0, it means it's that flower is in the class of roses. If it predicts 1, it's a daisy. If it predicts 2, yeah, up to 4. And then now we are able to, also for the images, the model won't be able to understand the images the way they are. So we need to convert them into NumPy arrays, not into into arrays. Or I hear some people calling it tensors, though I think anyway it's maybe the same thing. And then there are these basic functions which come with pandas. It's a library for Python for data manipulation. You can check the shape of our flower, which is that 240 by 179 by 3. But it's always a good practice to ensure that all the flowers are in the same shape. Because now if I was to open the folder, we will find that not all the flowers are they have the same length, the same wing. That is why I was doing this. And CV2 allows you to resize just by doing this, CV2.resize, using that method. And then you're able to resize it to that shape. And then now when you maybe print out that, you'll find that the shape is that. And then now I want us to, now if you have done machine learning, you will see that we always need training set and testing set whenever we are training our models. So that we train it using now the training data set, and then we evaluate it using now the testing one. And if all of them work quite well, it's a good job for you. But for now, because you're just downloading it, that is why I'm not using scikit-learn here. There's a method called train test split, which most of us use. But for now, I just make these 2 dictionaries and then append the various data into that. I'm really sorry for going through it quite fast, but I see time is not in our side. So now whatever we have done there is just making our X and Y lists. So you can see the length of our Y using the length of function, which is 799, meaning that is those are the number of flowers that are there. Then now we convert now the Python lists into NumPy arrays, because okay, I don't know whether you can still work out with the list, but in a way they will be somehow disturbing, because NumPy is very simple when it comes to some stuff like scaling, whereby you need to scale your data for better performance of your model. It doesn't require a lot of coding or a lot of that. Yeah. And then now we have our training set and testing set. Oh yeah, this one is the one I was saying about now, scaling, whereby you just you divide by 255. 255 is the maximum. That is why we are dividing by it. But now if we were using Python arrays rather than NumPy arrays, probably we'd get some errors here, because I don't think whether it will divide all the values or something. And then now we come to our model implementation part, whereby we use the sequential API from TensorFlow, and we define our layers. Which has 16, how will I call them? Like the size now, the size of, the size of the image when it is converted. And then we have 3 here, which is called what is it called? It has a name, which is probably like a square, which is 3 by 3. It can be 2, it can be 1, not a must. And then we have padding. Padding comes with, we have same padding and valid padding. Valid padding is whereby padding does not take place, and for same, it's padding basically allows the neural networks to also involve the edges of the images, because you find that most of the time it doesn't take part, and that is not really good. So we use padding to ensure that all the parts of the image, even the ones at the edges, they participate in all that. So we have our activation review there. There are various activations like sigmoid and all that, but for now we are using this. And then we are doing pooling. Yeah. And then this is basically the training now that takes place. And I was kind of lucky. My model had accuracy of 100%, which I wasn't believing, and I was really shocked. And so I had to evaluate it, and also evaluating it on the test data, I also got an accuracy of 1. So I think it quite performed really well. So now, for example, we can come to just a minute. Yeah. So we have this part here, whereby you can see the various classes, meaning the first flower had a class of 0. The next, quite a number of them had 0. And then I only find one having 1. I'm finding where we made the labels. So meaning that the first, I don't know, 3 of them were roses. Then we can see a daisy. Yeah. So that is basically how you do it. So now the only thing that changes is the data you are using, depending on what you want to build, and maybe on how you implement various parameter tuning here when building your model. So I think that's it for now. And, okay, if anybody has a question, you can ask. I really went fast, but okay, yeah.
Hello, good afternoon, everyone. I really want to thank our presenter for the wonderful and very educative session. Thank you very, very much. It is a very, very beneficial one. My question is, while you were talking, you talked about convolution layer, that it picks a particular part of the image. So now, the question I want to ask is, how many convolutions will we need to pick information from the entire image?
Yes, how many convolutions will you need
To cover the entire image? How many convolution layers will we need?
Now that question is quite tricky, but as I said earlier, most of these things you can just try them out. Like for example, now you might try with some few layers. Then if it doesn't work, then you can maybe try on others. There's no specific number. Like now in machine learning, how I know it, there's no specific way you are sure it will work. It's just trying. If these layers do not work, then you try to add some dropout layers. You try to remove some other things. You try to implement some arguments. Yeah, something like that. I don't know whether I've answered your question. There's no exact number or specific number.
Yes, you have answered my question. Thank you very, very much.
Okay, welcome. Okay. Any other question?
Ephy,
Yes.
like what you are talking about, are you saying fine tuning? Is that what we call fine tuning? Or
Yes. But fine tuning mostly comes in the part I was talking about, transfer learning. You remember that part?
yeah.
Yes, but it's somehow similar also. So is there any other question? Okay, so I'd like to thank all of you for participating and for taking your time to listen to me, and I've also enjoyed for the session. And also thank Victor, Jacob, and the Machine Learning Uyo community for the opportunity. And I also hope to engage more and more. Thank you so much. So I think I'll just take it back to Victor.
Thank you everybody for joining, and thank you very much our speaker for making time to handle the session today. We have really talked about a lot of things, starting from neural network and how the applications of computer vision and a lot others as well. So you have said everything, or and just to, I don't know if there is any other question or any other contribution that anybody wants to add to the session to as regards to convolutional neural network. So, well, for the question that was asked earlier, I think the number of convolutions needed to cover an image depends on the size of the convolutional filter kernels and more like the dimension of the image itself. So there's no actual there's no actual one way or number of convolutions of layers needed to actually cover an image, and one of the factors depends on the pixels. Okay, so most times if an image has higher pixels, then you will need at least a number of convolutions to be able to capture all the data effectively very well. So I'm going to drop the link to the group, to the WhatsApp group. I would really love to engage and interact with everybody. Is there anybody that wants to say something or wants to, like, I really love to connect with every single person out here. So so there is a Google group we have, and we do send mailing lists to everybody in that group. So like this session today, if we are in that group, you get it via email. So I'm dropping the link in the chat section right now. So you'll be able to join the group via the link. Yeah, so we are going to continue our session on Thursday, same time, same meeting link. So please, once you come across the flyer, make sure do well to share it with your friends, share it to your network, share it with every other single person out there. And next week we are starting machine learning study jam. Machine learning study jam is going to run for about a month, and Monday, Tuesdays, and Thursdays from next week. So thank you all for joining. So at this point, if there is no other question, then our speaker tomorrow will take us on machine learning modeling. Thank you all for joining. So thank you very much, Effie. Thank you, Amin, and the entire Aorist Artificial Intelligence Labs. Yeah, that is really, really great. Thank you. Okay, bye.
Bye.
Okay,
Thank you for today. It was great.
you're welcome.